Let's now give a precise definition of this informal compound data structure that we just saw. So a list is a recursive data type. So that means it's defined in terms of itself. Note that recursion is used both for computations, for example, when we define functions, and for data, for defining data types. And this is important because when we start writing functions to do calculations on lists, the function, which is going to be recursive, is going to follow the recursive structure of the data type. So it fits perfectly. So how do we define a list? A list is either an empty list or a pair of an element of a given type followed by another list. So this definition is recursive because it defines lists in terms of lists. There is no infinite regress in this definition because we are going to use it constructively to build larger lists from smaller lists. So we're going to start with the empty list, nil, and we're going to build larger and larger lists. Okay, let's now introduce a formal notation. So we're going to define what's known as the syntax of a list, which is the textual representation of a list. So we're not yet at the point of defining the semantics of list. That will come. Don't confuse syntax and semantics. The textual representation is just the surface, but it's an important surface. Semantics is what's going on underneath. For now, we're going to define the syntax of a list, and the semantics will come in a later lesson. So we will define the syntax using what's called an EBNF grammar rule. So EBNF stands for Extended Backus-Naur form, which is a very popular way of defining syntaxes invented by John Backus and Peter Naur 50 years ago. So in this rule, list T represents a list of elements of type T. : equal means is defined as. Nil is part of the syntax you want to define. Vertical bar means or. T means an element of type T. A vertical bar in quotes means a vertical bar in the syntax we're defining. And here we again have list T. So this says a list of type T is defined as either nil, N-I-L, or an element of type T followed by a vertical bar followed by another list of type T. Okay, so be careful to distinguish between the vertical bar without quotes and the vertical bar with the quotes. So the first is part of the grammar notation. It means or in the grammar notation. The second is part of the syntax we're defining. So we have to have some way of distinguishing the two. So the quotes are used for that. And so in the syntax we're defining just a vertical bar. So here's some examples. So assuming now T is an integer type, we have nil, the empty list. We have 10 bar nil, which is a list with one element, just the number 10. 10 bar 11 bar nil is a list with two elements, and here we have a list with three elements, and so on. So what about the bracket notation we saw in the previous video? Actually, it's not part of the recursive definition of lists. It's something extra called syntactic sugar for the programmer's comfort, and we will look at that later. So let me be now very precise about what we're defining here. So with this angle bracket notation, angle bracket int, angle bracket, this represents an integer. Actually, that's not quite right. It is the set of all syntactic textual representations of integers. And angle bracket list angle int angle angle represents a set of all syntactic representations of lists of integers. And the T represents a set of all syntactic representations of values of type T. We say that T is a type variable. So we now have three different kinds of things that could be confused: type variables, identifiers, and variables in memory. Three completely separate concepts that should not be confused. A type variable exists only in a grammar rule. An identifier exists in a program text, and a variable in memory exists conceptually in memory while the program executes. So to finish now this unit, let me recall an important lesson that is given to us by the surrealist painter René Magritte. So this is a very famous painting. The title of this painting is Ceci n'est pas une pipe. This is not a pipe. And this painting is definitely not a pipe. And in fact, someone asked Magritte, but what is it then? How come it's not a pipe? And Magritte said, try stuffing it with tobacco and you'll see that it's not a pipe. So this is a digital to display of a photograph of a painting of a pipe. Unless you print it out, in which it's a printed version, etc., etc. So what's here on the bottom of this slide is not an integer. Analogously, it's a digital to display of a visual representation of an integer using numeric symbols in base 10.